Hello guys, so today I'm gonna share with you a tool I made for restoring a broken Minecraft world. As you can see here, when I open my world, this happens. All the chunks are out of place. And if I fly around, yeah, see, I get messages, failed to load chunk at some coordinates. And if I look at the logs, it says chunk file at -1458, or for other chunks on other locations is in the wrong location, relocating. Expected this, got this. This happened after my Minecraft client has crashed. It actually just hung and I had to quit it manually. And then I opened the world and I see this. So in order to fix this, we need to first understand why this happens. So all the chunks in a Minecraft world are actually stored in region files. A region is an area of 32 by 32 chunks. The files in the folder region actually only store block data, and entity data is stored separately in entities folder. Today we are only gonna deal with blocks. So this region folder is for overworld, but if we go to dim-1 and region here, this is for the nether, and in dim1 this is for the end. Now we need to understand region file format. This is a great article on minecraft.wiki, I will leave a link to it in the description. So the file is made up of so-called sectors. Each sector I will represent with square brackets like this. Each sector is 4096 bytes long. First two sectors are for a header, and all the rest actually store chunk data. So the most important one is the first sector. The second sector stores timestamps for when a chunk was last modified, but it doesn't really affect how you play in the world, and we're gonna disregard it. So the first sector is a table of chunk locations in the file. It's a 1024 array of 4-byte values. Each value represents a location of a chunk. So as you may notice, if we have 32 by 32 chunks in a region, it's exactly 1024 chunks. For example, we have this value, then this value, and so on. So a value at index I actually strictly represents a chunk at location of modulo 32 and floor of I over 32. You can read this in the article here. So first one represents chunk at 0, 0, this represents chunk at 1, 0, and so on. So first 3 bytes of this value represent the index of sector where the chunk is stored. So here we have 2. Here we will have chunk data for chunk at 0, 0. The last byte says how much sectors chunk data for chunk 0, 0 actually occupies. 2 chunks. It may not span the second chunk entirely, so we may have some junk data here. So this one says that we will have chunk data for chunk 1, 0 over here. If say it spans just one sector. So this is how it works. So what ended up happening is that Minecraft got halted mid-write operation, and the table got misaligned with the chunks. The table, for example, here, if it starts pointing like this, it actually points to this chunk. When here we're supposed to have this one. So the Minecraft looks for the chunk at 0, 0. It sees that the data for the chunk is supposed to be over here. It reads this data, but in the chunk data there is also internal metadata for where the chunk is located in the world. It sees that the internal metadata mismatches the table, and then it actually corrects the internal metadata, not the table. So the table is preferred over internal metadata, and that's why everything goes wrong. The table misaligns with the chunks, and the chunks get out of place entirely, and everything is corrupted like this. Before you exit Minecraft world and everything is saved in a wrong state, the internal metadata actually retains, and you can use it to correct the table. For that there is this tool I found. It's a great tool. I didn't write it, it's somebody else's tool. It can do more than this, but it actually can correct the table according to internal chunk metadata. So it works unless you enter the world and exit it, or just press escape, because it's like saves the world once you press escape, and pretty much randomly at any point and can save it. And if it saves the world, then the internal chunk metadata is rewritten, and here it writes like 00, and then there is no easy way to figure out where this chunk went originally. And my tool actually aims to fix that. The way it works, it actually uses not just the corrupted region, but it uses a so-called template region. So a template region is the same region file, either from a backup of your world that is too old that you don't want to use it for restoring your world, but you can use it as a template, or you can regenerate a new world with the same seed and use that. So for example, we have a template chunk, a chunk region, the mountains here that I attempted to draw, and this is the wrong chunk, the one that got corrupted. It may be that you have built something here, so like a house here. It takes each chunk of the fresh new region, so for example take this chunk, and then it searches through all of the chunks of the corrupted region and selects the one that matches the best, this one. So for matching there are a couple of different matching algorithms. The best one is matching by bedrock for now. At least it's the best for the overworld. It's not gonna work in the end because we don't have much bedrock there. But bedrock patterns are a very reliable way to identify chunks. So it looks for the chunk that looks like this one. For example, it found it here. So then it places this chunk here. It searches for the best matching chunk for each chunk. For some chunks it may not find any match. In that case that chunk is lost. But most of the time most chunks can be restored. It's just like a couple unlucky chunks that get lost completely. So first my tool actually scans through all of the chunk data, disregarding the table completely. So this table, it doesn't even use it. Actually it can find more than 1024 chunks. That's because say here we have data for a chunk like at 10.0, and here we have data for a chunk at 8.0. So for example, then you build something in chunk 8.0 and the data for the chunk can't even fit here. So it uses like compression algorithm, and if the chunk got more complicated, then it may not fit in one sector. Minecraft needs more than one sector, but there are no like empty sectors here, it can't put it here. In that case it's gonna leave this chunk data here, place here at the end of the file. So this is now just an orphaned entry, and nothing in the table points to it. And the actual chunk data, the newer one, is stored over here. That introduces a problem. That as well with the fact that when the world is corrupted, Minecraft may attempt to regenerate some chunks entirely. And in that case we may have multiple chunks matching for one. So say for example for this chunk we have this guy matching, and also another chunk that also matches this one by bedrock pattern. So say this one is from an orphaned entry that doesn't go anywhere, and this one is with your house, and you need to choose this one, not this one. And for choosing the correct chunks when there are multiple candidates, we use so-called resolver algorithms. There are multiple ones, but the one I prefer is to use a fresh regenerated world. So the template regions are from a backup, but the regenerated ones are from a fresh new world with the same seed. So we have like a separate region for that was freshly regenerated somewhere there. And what I do is I compare these two candidates to the respective chunk from the regenerated region. And the one that matches it the worst is the candidate that I choose. So when you build a house, you modify the chunk. So it's gonna be more different from the fresh new world. And the one with the house will be preferred in this case. But sometimes when the Minecraft regenerates the chunks in the environment of jumbled up chunks already, like that chunk is surrounded by other chunks, the generation for it may change a little bit, so it's gonna be different. And in that case, the resolver may fail and choose the wrong option. In that case, you can also choose chunks manually. So this is basically how it works. I hope that was not too hard to understand and I didn't miss anything that I should explain. Now let's go over how it works. This is a Python tool, it's made with Python. I didn't make an exe, is it, what's the pronunciation? Exe, like, you know, this type of file for Windows. Yeah, anyways, it's just a Python script, .py. So to run it, you need to install Python. You need to also install some packages. For that, I'll have a separate requirements file and the instruction will be on GitHub. You can read it there once I publish it. Once you install everything, you go to the folder, open command line, or in my case, since I use Linux, I open terminal, type python mca restore.py, and see it runs. So it just needs the arguments -, we see the help message, which briefly describes all the features. First we type here the path to the corrupted chunk, then we provide the path to the template, then we provide the path where we need to write our restored version. And this is already gonna run. Then let's go over the options that it has. So this is like position arguments that I discussed already. Match option is the most important one. It chooses how exactly do we try to match the corrupted chunks to the template. So the default option is bedrock. It matches the bedrock pattern, but we can also use features algorithm. This is an algorithm that I came up with. It's a rather sophisticated algorithm. The way it works is it isolates the areas where a lot of blocks match. Or for example, this area with call, if it matches to some chunk of a template, then it counts how many features are in that matching place. So a feature is a block which is adjacent to a block of different types. So like these ones are gonna be considered features and these ones as well. So it counts how many features match, so that if a lot of air matches or a lot of just plain stone, it's not gonna count that at all. And it's a pretty robust algorithm for matching chunks and finding which ones have matching patterns. But in case we have bedrock is obviously way more reliable. That matching algorithm yields how much features it found, and then that value is compared to threshold. So if it found more than threshold, the chunks are considered matching. For bedrock algorithm, it's the opposite. It counts mismatches between bedrock blocks and compares them to threshold. So if less bedrock blocks mismatch, the chunks are considered to be matching. So by default, threshold is 0, so we need to have perfect match for bedrock. And then the last algorithm is diff. It's same as bedrock, but it compares not only bedrock, but all blocks entirely, like just block by block differences. It's less robust than bedrock algorithm because obviously you can break and place other blocks, but you probably can't do that with bedrock unless you like use glitches and stuff. This is the option for resolver. So by default, if we have multiple chunks that match equally the best by the matching algorithm, we need to resolve that conflict and choose the one which is the better one, and we run resolver for that. But if you provide all candidates option or just -a, it's gonna resolve not from all the best matching ones, but all the ones that just match, like below threshold. So if, for example, if you have one bedrock broken and you provide threshold of 1, it can find two different candidates, for example this one and this one. It's a regenerated chunks and it doesn't have any bedrock broken, and this one has like one bedrock broken. And in that case both of them will match, but the one with no bedrock broken will match better. So by default it will choose the one without broken bedrock. But if you provide all candidates options, then it's gonna run the resolver on those two chunks. Now the resolver. It has multiple options. Max diff chooses the candidate that matches the worst, and min diff is the one that matches the best to the template. Or not to the template, but to a separate file to the resolver template. As I already mentioned before, we can use a separate regenerated region other than our main template for the resolver, and we just provide it to the resolver template. Then we can have max features or min features. So in case you've built something in your chunk, you're probably gonna have more features. So in that case you can choose max features. But if you just dug up the chunk instead, then you probably should use min features, in case you don't use max default. Last ones use the same algorithm. Features different chooses the candidate that is most different, and the features similar that is most similar according to my features algorithm. Now fill option is for filling the chunks that it failed to restore. So for example, if for a chunk we can't find a candidate at all, by default it leaves the chunk leaves it out completely. So when you open it with Minecraft, it's just gonna regenerate it anew. But if you provide a fill option, it's gonna take a chunk from template, the main template, not the resolver template, the main one that you provide here, and it's gonna take the chunk from there and place it. You can provide here a list of chunks that you want to discard, to not include in the restored version. So for example, if for a chunk it can only find a regenerated version, but instead you wanna use the one from the template. Say in a template you build a base for a house, but instead it finds a fresh new regenerated version. And if you don't wanna use that one, but instead you wanna replace it with the foundation of your house by using fill option, you can manually discard it by providing it into the list in this format. And the last option, choices. You can use this in case the resolver fails to find the proper candidate. In that case you can choose candidate manually. So it's the same format. You first select a chunk and then you place a colon and the number of candidate that you wanna try using. Now let's actually run this. So I'll provide resolver template as well, and here we go. First it scans the corrupted region. It finds more chunks than there actually are in a regular region. It parses the templates, and here we go. Now it tries comparing different chunks. It's gonna take a while because it needs to compare on average like 1024 to 1024 chunks, so it's gonna be more than 1,000,000 comparisons. And here we have some warnings. So already we don't have a candidate for a chunk, and here we have no candidate, so these chunks are lost. And here we have multiple candidates for one chunk, and it chooses one via the resolver. Here we go, it's done. So now here we have the restored file, and also there is this file which is catch for. So now if I rerun it, it's gonna take way less. As you can see, now it parses everything, and now it's almost instant, all the comparisons, because it saved them. For testing, I advise you to create a separate super flat world and place a stored chunk there. So here, place it over here, and here we go. We see this region in the super flat world. As you can see, some chunks are actually missing, so it wasn't able to restore these chunks, for example. Here we have a gold farm and a sugarcane farm that actually got corrupted. As you can see, this chunk mismatches it. If I enable chunk borders, this tree is out of place. So we will need to fix that. And also, see this? See this? This thing is floating, and we have this chunk which is totally out of place. What we can do to fix this is we can go, first of all, figure out which chunk it is. Wiki page, there is this tool. We can put our coordinates into this tool. So it's the chunk at 6.3. And now let's go to the trace of my script and see what does it have to say about the chunk at 6.3. So the chunk at 6.3 actually had 3 candidates, but it has chosen candidate 0. Now let's provide the correct candidate, 3.6, and we choose candidate 1. Turns out I didn't notice, but this chunk is also out of place. This is chunk at 5.1, and I also choose a different candidate for it. Main farm was cut and all the trees are also cut. So this is a chunk at 3.0, and we look at the trace. Okay, so I'll also choose candidate 1.
Now let's try this again.
I rerun it with all the manually chosen candidates. As you can see, the rest of this sugarcane farm, at least what feeds in this region, is here. And let's go over those chunks. As you can see, oh, why did this not work? Oh, I just misspelled it. It's I wrote 3.6 instead of 6.3. Yep, now it's filled. Now once you painstakingly fixed manually all the wrong choices, at least all you can see, you should run this with -F or other -F option in order to fill all the missing chunks, at least if you have a backup. If you don't have a backup, yeah, then it's not gonna help. Then you can just leave them out, and once you place this region in the world, in the correct one, the Minecraft will regenerate this terrain like a new restored region. And I reopen Minecraft. Now everything is filled, as well as this tree farm, so it filled this tree farm from the backup that I had. So now we have a pretty normal looking region that is restored as well as it can possibly be, probably. And just compared to how it was before. So this is how this region looked before, totally messed up, as you can see. Then you just repeat this process for all your corrupted regions. Here, as you can see, I restored an adjacent region, and here we have some problems, like this chunk is missing. It wasn't able to find a candidate for this chunk, and here, as you can see, this house was cut in half. Like this chunk, this one is mislocated. So for this chunk we also need to choose the correct candidate. We have two candidates, 0 and 1, with the same resolver matrix, or resolver was indecisive between these two candidates, and these two candidates are probably just one same version. They probably match perfectly. So it chose candidate 0, and thus I think the correct candidate is probably gonna be the candidate 2. So let's choose it. I identify the chunk by the block coordinates, in this case 72 983, and choose option 1 and choose the candidate 2. And here we go, the house is here, and the items are also here. So after you restored all the chunks, all the corrupted chunks, you go ahead and restore your corrupted world from a backup you made after the corruption happened, and then you replace all the corrupted chunks with the restored versions. Now upon entering your restore world, you may notice there are still messages failed to load chunks that pretty much look the same as the problematic ones before. But actually this happens because the entity regions, the ones that hold entity data, also got corrupted somehow. And this is actually not a huge deal, because I suppose each entity also has its location stored internally. So even if it's like mislocated in the different chunk, it's Minecraft places it where it needs to go. The only problem is that when I tried opening this world with a big render distance, like 32 chunks, it hung indefinitely and I was forced to crash Minecraft. And I think that's related to the entity regions, because if I delete those, it opens even with the great render distance. But with lower render distance, you can just open it with no problem, and I think it fixes itself, like all the wrong entity regions. All the entities seem in place, like all these item frames, except maybe for one cat. Like here was a cat, it was sitting here. I don't know where it is, why is it gone. That's sad, but apart from that, everything is here. That happy ghost is in his wooden cage. All the villagers, everything. So yeah, this is it. Hopefully this was helpful. And one last thing I wanna say, if you ever open your vote and you see those failed to load chunk messages, you should close it immediately. Preferably you should... What is this? I never built this. Somebody built this guy here. Yeah, so you should close your Minecraft immediately, and preferably you should just unplug your computer so that it doesn't get to save all the wrong chunks, because the more you load it, the worse it gets actually. And then you make a backup and try to restore it as much as you can. So this is it for today. Hopefully I was helpful, and this helps somebody restore his broken Minecraft code. If you have any questions or suggestions, leave them in the comments. Yeah, sorry for my English. Goodbye.